New images from the James Webb Space Telescope surprised scientists. Rather than expanding our understanding of the universe, these images revealed an alarming fact. Our current physical understanding is insufficient to explain the nature of the cosmos in its early stages. As the Big Bang Theory reaches its limits, we are forced to consider new hypotheses about its origins. The question arises how exactly the universe was formed and why. This new discovery will challenge even the most experienced astronomers. To learn more about the Big Bang and the revolutionary details of the discovery, let's recall the concept of the Big Bang itself. Contrary to popular belief, the Big Bang was not an explosion in existing space. Rather, it was space itself, born some 13.8 billion years ago along with matter and time from a primordial singularity. In physics and astronomy, singularities describe places where gravity is so strong that the curvature of spacetime becomes infinite. Today, billions of years after the creation of the universe, we find that our cosmic home is part of a fundamental process. To experts, it represents an intrinsic property of the universe since its existence. Its seemingly endless expansion. It is important to understand that space does not expand into existing space. Rather, the space itself is constantly growing. According to traditional theories, the first stars began to shine 200 to 300 million years after the Big Bang, marking the end of the so-called Dark Ages. Then the first bright objects in the sky gathered and formed mature galaxies. But how fast these galaxies grew is still an unsolved mystery. In July 2022, the first images from the James Webb Space Telescope provided an important clue. Experts reported that the telescope detected several galaxies, some of which existed already 300 million years after the beginning of the universe. But compared to the galactic structures that evolved millions of years later, these early galaxies remain significantly smaller and less massive. This fits perfectly with the scientific model accepted by scientists. The density of matter in the young universe was simply not enough to produce galaxies the size of today's galaxies. What began with James Webb's discovery of 6 bright redshift points has triggered one of the most significant astronomical crises of our time. Although these newly discovered galaxies are similar in age to previously recorded galaxies, they are nearly as massive as our own Milky Way. This has created a fascinating puzzle for astronomical research. After examining the images taken with a near-infrared camera, the experts identified the aforementioned light sources. Using redshift, scientists calculated that it took more than 13 billion years for the light from these objects to reach our eyes on Earth. That is why we are talking about structures that existed already 500 to 700 million years after the supposed Big Bang. Analyzing the properties of these structures, it was concluded that the Webb telescope captured the image of 6 very early galaxies. Surprisingly, these galaxies were so massive that they defied normal cosmological expectations. Instead of finding the expected dwarf galaxies, structures almost as massive as our own Milky Way were detected, although they formed earlier in the epoch. If we continue to analyze the data collected by the James Webb Telescope, this collection of gravitationally bound stars was already more than 10 billion times the mass of the Sun, with one possibly exceeding 10 billion solar masses. But even considering this possibility, the mystery is not completely solved. Even in this scenario, the early universe would have a significantly higher stellar mass than previously assumed, creating a conundrum. The observed objects contradict almost all conventional cosmological theories. Even if only one of these galaxies turns out to be genuine, it calls into question our previous assumptions about how these structures exist. In addition, the density of matter in the early cosmos would have to be up to 5 times higher than supposed to explain this phenomenon. Another equally mysterious explanation is based on the fact that these galaxies evolved in a way that is still completely unknown to us. These discoveries, and the debate surrounding the Big Bang, force more and more scientists to abandon this theory. Many astronomers with alternative views are frustrated that they are not heard in scientific journals. Even those who express doubts about existing theories are often labeled as baseless eccentrics. However, it is undeniable that even experts who still defend the Big Bang Theory are constantly faced with questions that do not have clear answers. These questions include specific questions like why and how did something literally come out of nothing 13.8 billion years ago? Can something really come out of nowhere, or was there some sort of triggering event, or was it all just a coincidence? Stephen Hawking pointed out that the concept of time as we know it only began with the Big Bang. Therefore, nothing else or an outsider could initiate this process. A similar controversial issue concerns the uniformity of radiation and density throughout space. No matter which direction or distance we look on the larger cosmic scale, we find similar densities and distributions of galaxies, nebulae, and radiation everywhere. Conservative scientists explain this phenomenon with the theory of cosmic inflation. However, other experts take this assumption further with the theory of chaotic inflation. According to this idea, it is possible that inflation stopped only in some areas, such as bubbles, and continued indefinitely elsewhere. This means that multiple universes are forming in these bubbles, each with its own physical laws. This model raises a fundamental question: what if the cosmos does not represent a perfect whole? And even more, what if another universe existed before ours? In this case, the Big Bang would become part of a larger cycle. According to this perspective, our universe is part of a larger multidimensional structure. In this model, the idea of an eternal cycle of collapse and rebirth of the universe is presented. However, this is not the only perspective in the field of cosmology. Besides the Big Bang Theory, for example, in 1955, NASA's Cosmic Times published an article asserting that the Big Bang could never have happened because the universe existed for an infinite amount of time. According to this point of view, the expansion of space would be non-existent, and the continuous creation of matter could give the impression of continuous expansion of the universe. Another fascinating, albeit controversial, theory comes from the world of quantum physics and string theory. Some experiments are said to have shown that our universe and everything in it does not exist. Simply put, what we see as the visible universe may just be a flat hologram projected onto a sphere. Therefore, it is possible that our reality is the result of a higher simulation. Although this may sound like the plot of an imaginative science fiction film, it can be connected to the Kardashev scale, which measures the level of development of a civilization according to its energy use capacity. If there was a Type 3 civilization that could fully utilize the power of the entire galaxy, it could have created a perfect simulation. However, finding out the truth in such a scenario is a very difficult thing. Exploring the depths of cosmology and the origins of our universe leads us into a world of deep mysteries and ongoing scientific research. Recent images from the James Webb Space Telescope have reignited the debate about the fabric of our existence, challenging established theories and prompting scientists to rethink fundamental aspects of cosmological understanding. This research focuses on the Big Bang Theory, the cornerstone of modern cosmology. According to this theory, the universe began about 13.8 billion years ago from an unimaginably dense and hot state that rapidly expanded and gave birth to space and matter as we know it today. This cosmic event is not just an explosion in existing space, but encompasses all origins.